Hello and welcome to the Daily Space. Today is somehow only Thursday and not yet Friday. And it's going to be one of those days that actually feels like a Monday. So we're starting a little bit late today, and the reason is actually pretty cool. So we've been working on doing a final review with 8 specially selected citizen scientists of the potential landing sites for the OSIRIS-REx mission on the little annoying asteroid Bennu. This rock and rubble pile is really annoying to map. And, we've been trying really hard to find that safe enough place for our spacecraft to go down, grab a sample, and come back up. Well, initially, we knew that we only needed 1 or 2 people per image to look at the images, but we figured, hey, for better statistics, let's just get everyone to look at these final images, all 8 people. Except these images are super annoyingly rocky. So we've cut the number down to 2, and this morning, quite by accident, we discovered, hey, when we do that, it turns out we're done with this initial set of images. New images are going to get posted as soon as I'm done recording this episode and before we go record the podcast. So you guys out there, and you know who you are, you 8. You're doing a really awesome job, and your job isn't over yet. There is more yet to come. So as I come to you now, I'm still in the process of opening up all the things I need and getting everything going so that I can actually read the chat. And it turns out I'm going to actually be missing the past couple minutes of chat just because I opened the wrong window on my laptop. So we have been working to figure out how to build the better studio for this show. And I think I finally figured out the answer, and that's to have a computer that controls everything over on the end of the room, to have a fixed camera on a tripod in the middle of the room, and to have all of our sets such that it is rotate that camera around to get each of the different setups we need depending on, what we're doing, unless what we're doing is programming, in which case I'm upstairs on a programming computer. Now, this is all possible thanks to old computers. Never get rid of your old computers. Just keep them in case you someday need them. So I'm like reading chat on the oldest laptop ever. Yes, there is a dog cam too. It's just the dog was asleep in a kind of awkward place today, so I didn't pull up the dog cam. So we still do need to make a few things, as is correctly being pointed out in the chat. Doggos do like to move tripods. So there was a bit of chaos earlier today going, oh no, where did he bump the tripod to today? So we're going to be working on figuring out how to prevent the dog from moving the tripod, and also sharpening the cement floor down here with circles indicating where the tripod needs to live. But things are settling down. So that's why I'm running late today. I had awesome news, and then I also had a dog move the tripod. But this isn't to say there isn't all sorts of science news for today. I actually had to bump some of the stories to tomorrow because there is so much going on. So let's take a look at that science news. Our first story is the continuing drama surround measuring the expansion rate of our universe. As we brought up, I think a month ago at this point, one of the ways that you can measure the expansion rate of the universe is to actually find gravitationally lensed images or gravitationally lensed views of distant quasars. So what's happening here is you have a foreground galaxy, and then behind it you have a single quasar. And as the light from this quasar spreads out in all directions, the gravity from that foreground quasar is going to bend some of that light that was meant originally to go somewhere entirely different in the universe. It's going to bend some of that light to, well, where we can see it here on the planet Earth. Now, that extra bent light, thank you for the bits. Thank you. That extra bent light, it goes different distances depending on where it was bent from. This means that when we look at systems like those shown in this image, where you see multiple versions of the same object. In the leftmost image, you see 4 bright points, which is one quasar repeated 4 times. In the middle image, you see 4 kind of distorted, not as symmetrically displayed images. In the right image, you see an arc and a bright point. Those are all basically carnival mirror versions of the same object. And because each of the light paths is a different distance, we can use time delays in light to measure the differences in the distances and get at the expansion rate of the universe just by using a whole lot of geometry. It's not easy. It's more complicated than what I described. And what this team did was they looked at systems where the background quasar is flickering over time. And they looked to see when each of the different images had a distinctive, pattern in its brightness change over time. And by getting at these differences in timing, they were able to get at differences in distance. And to make sure that they were completely not biased in how they did this and didn't inadvertently do something that made the results come out one way or another, they reduced each image separately, made sure that their analysis had gotten rid of all possible bias, and only after they were complete did they recombine all of this data to find out what they had measured in what way and what the resulting expansion rate of the universe would be. And they promised that no matter what the result was, that was the result they were going to publish. And what they found is their result matched the results that Adam Rees and his team are finding as they measure the expansion rate of the universe using supernovae and new calibrations of pulsating variable stars. These near-universe measurements are all giving us a value of the universe that is younger than had previously been expected and doesn't quite match what is being seen when we look at the cosmic microwave background. And this growing discrepancy that isn't going away as we use different ways to measure the expansion rate, this seems to indicate that there's a piece of physics that we're missing that connects the history of the universe and how it has evolved over time between that formation of the cosmic microwave background and the evolution that we're seeing today in the geometry of the universe. It's cool to learn that there's something fundamentally unexplainable about our universe that we still need to figure out. This is the kind of problem that drives astronomers. We like mysteries, and this is one amazing mystery. Now, not all of today's news is quite so grand, but the pictures are just as beautiful in our next story. This is a massive galaxy that is located 12.5 billion light years away, which means the light that we're seeing has been traveling to us for 12.5 billion years. And we're seeing how this object looked when the universe was just a baby. And they actually referred to the universe as a toddler in the press release. I'm not sure how a universe toddles. I'm not sure I want to find out. But the universe was much younger than it is now. And this beautiful image was actually discovered entirely by accident. It was in the background described as shimmering in an image that was taken using the Atacama Large Millimeter Array. And this image um, is of an unexpectedly large galaxy in the early universe. It, at the point of this picture, appears to have about as many stars as our galaxy has today, but it's undergoing massive amounts of star formation, forming roughly 100 stars per year, they estimate. And this is a formation rate greater than that of our entire local group of galaxies. Now, finding something like this really helps fill in a blank spot we had in our galaxy formation history. We've seen extremely massive, mature looking galaxies that are far back in our universe's history, but not this far back. And we'd begun to get the sense that galaxies actually form in two different ways, with the majority of galaxies forming out of the gradual buildup of small objects coming together over time. But some systems that appeared formed through the giant collapse of massive amounts of gas and dust that formed right off the bat massive galaxies. And this is one of those galaxies. And now we're getting to see it form. And we don't actually know how common systems like this are. This was found by accident in an image that was just 1% the size of the full moon. And the question is, did we just get super lucky in accidentally finding this image? Or are systems like this regularly scattered across our sky? I would love to be able to do a survey of the sky with the Atacama Large Millimeter Array, but unfortunately its field of view is so small and the time it takes to acquire images like this so great that this kind of a survey just isn't possible. There are too many dedicated images that still need to be taken with the ALMA array. But this hints at the kind of thing that is yet to be found and documented. And it's hoped that, well, maybe once we get the JWST telescope launched, it will be able to help out in the discovery process. One of the reasons that these kinds of systems are so hard to measure is this light is only visible in radio and potentially infrared light. This is a dust-enshrouded system that is otherwise blocking what we would see in other observable colors. So this is kind of cool. And today is really a day for weird stuff in our universe. And the next story continues this weird stuff in the universe kind of trend. This is an artist's rendition of two worlds colliding. And about 10 years ago, the Spitzer Space Telescope, working in conjunction with other Earth-based telescopes, discovered a binary star system that appeared to have a warmer disk of dust around it than could otherwise be explained. This particular system is about 1 billion years old, and while baby solar systems are really a hot mess, literally hot and messy, over time, solar systems settle down, worlds form, worlds cool, dust cools. And when scientists saw this system way warmer than was expected, this indicated that maybe there had been some sort of a planetary collision. Well, using the SOFIA Airborne Observatory, astronomers have gone back and given this system a second look and discovered that 10 years later, this system is 10% warmer than it was before. This indicates that, well, this probably is some sort of a collision, and the energy of that collision has gone into forming heat and debris, and we're looking at that hot debris of the collision. Now, we know that collisions occur, or at least we think we know, because it appears that our own Earth and Moon are the result of a younger, smaller Earth and a Mars-sized object colliding 3.8-ish billion years ago. And now maybe we're seeing one of these systems shortly after that collision. Now, there are other possible explanations, but they don't seem to fit the data as well. It's possible that the dust in the system is migrating towards the stars and heating up as it goes, but the 10-year timescale doesn't seem to be sufficient to explain what we're seeing. It's possible. It's also possible that the dust is recently formed and just absorbing heat from the stars, but again, the timescales for that don't seem to make sense. So this is cool. And I'm hoping that we get to watch this system over the years to come and learn more as we watch it evolve. And that rounds out all the stories I've got for today. And I'm now going to hang out and answer your questions. And while you type them in, I'm going to remind you to please use that purple circle with a darker purple star to note where your questions are in the chat. And I'm going to remind you that we are a production of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are produced by Susie Murph, and we are here because of you. It's your donations, your bits, your subs that make everything we do possible. One of the best ways that you can support us is to follow us over on patreon.com/CosmoQuestX. Your monthly donation will get you access to transcripts, show notes, extra content, information ahead of time on everything that we're planning. So let us give back to you for everything that you do for us. And if you can't financially support us, we get it. Just spread the word. Let others know. Retweet the episodes that you like. Follow us on Instagram. We actually Instagram a lot of the stories that we cover. And then, share us out, repost us to your feed. Help spread the word. You never know whose life you're going to change by introducing them to some science. Okay, let's see what all we have in the chat. I'm so pleased that my shirt does not actually want to green screen today. It's that kind of a crazy day where, work just went sideways. Okay. Kevlar 1066, thank you for your bits. Eddie is back asleep, so I'm not going to bring him up here. And his Vorverb comments, did the Kessel run in 12 parsecs? I actually have a talk that goes through and explains all the science in the Star Wars system as though it had a valid justification. And my theory is you can explain the Star Wars system as being a very young open cluster. So AstroWise asks, where does dark matter fit into the age of the universe discrepancy, if at all? So it does fit in terms of helping us get at the average density of matter within the universe. And that average density over volume is slowing the expansion rate as that gravity pulls back on everything. So this helps us figure out if we're at the critical density, if we will collapse eventually, or if the universe will expand out forever. Currently looks like we're at that critical density where, given the fullness of time, the universe will asymptotically approach stopping as it expands. If it was due strictly to mass, but because it's not due strictly to mass, what we're actually going to do is have the universe accelerate away forever. So yeah, our universe is one of those universes. That image I had earlier, that's a galaxy. I don't understand this image. I'm not going to lie. I don't understand why there's 3 bright points. I don't know if this is gravitationally lensed. I have only read the press release so far. My guess is that it is either gravitationally lensed or those are 3 big knobbly bits of star formation in a system that's still in the process of collapsing. Yeah, broken symmetries. Like she said, JWST, expect more delays. There are those who say every time you invoke its name, it gets delayed further. I hope that's not true. So Paranor asks regarding planetary collisions, could the Earth-Moon collision provide enough energy to allow conditions for life to start, allowing liquid, water, etc.? So the Earth-Moon collision was a bit too violent for that. It actually destroyed the two worlds. And this is more of a never-ending story kind of scenario where any life would be clinging to a fragment flying through space. But in this case, it's not like you can proclaim the name and have new worlds start. You actually have to wait for the debris to gravitationally reform into new planets or new worlds, as the case may be. What we are now finding, though, from what I discussed on Tuesday with the crater in Sweden, is it appears that once you do have a solid world, the impact sites do appear to be prime locations for life to exist. These locations probably would have had the added heat of the impact, the water brought in by meteors. Turns out meteors actually are fairly water rich in a lot of cases. We're at an interesting point where I think we're getting new clues as to what may have affected the origins of life on so regular a basis that maybe in the next few years we'll be able to really start to say what are the conditions that, well, trigger the formation of life. Let's see what else is in here. Keeper of Masks says, if you're in Canada or the northern U.S., down to about a line between roughly South Oregon and Maryland, you may be able to see the Aurora Borealis this evening. Check out the forecast at spaceweather.gc.ca for more. That is awesome. This is something I mentioned a bit on Monday, but it sounds like the new predictions have the extent of the aurora dipping even further south than was initially predicted. Definitely go out and look if, unlike me, you have clear skies. So Veronica Kira asks, have we found a planet with magma volcanoes yet? I don't know if we actually have the ability to tell if a system has magma volcanoes. We are reaching the point of being able to measure the compositions of giant planets, but trying to get at the compositions of small rocky worlds, well, that's a whole lot harder because we're still trying to find them. Stay tuned. Stay tuned. Looking to see. Henny's Vorverb asks, do you use strong or weak lensing to see galaxies that far away? This is strong lensing. That's a fascinating noise. I think that is the someone followed on Patreon noise. And thank you, human, for the thing that you did. No, that is Hot Row Bubba is now following. Thank you for the follow. Thank you so much. Eddie is like, thank you. You said thank you. Does this mean I get a treat? Come over here, Eddie. Come on over. No, Eddie, over here. Over here. Why? Why? You were going the correct direction. Come over here. Come on over here. No, come over here. You're on the wrong side. Okay, fine. 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 Thank you so much. Thank you, DB Vetter, for the follow. Thank you. So for those of you who don't know, when interesting things happen in stream, the dog demands treats. The dog has been trained that when I either say thank you with too much happiness or certain noises occur on stream, he's going to get a treat. So you can control the happiness of my dog by giving to our show. No arguing with Eddie today. No, there is no arguing with Eddie. I really want to train Eddie to come over to the other side of the piano bench that I'm sitting on. I'm just not there yet, nor is he necessarily that smart to figure out to go to the other side. And he's moving my desk again. Okay, so that's all I've got. And the next thing on my list is to go add more images to phase 2 of the OSIRIS-REx Bennu mapping project. You guys are awesome. And thank you. That's all I've got. Thank you. So, thank you, Trekker Kev. You're going to come back up, aren't you? Oh, you are. Wow. Hi. Hi. This is Eddie. Eddie likes treats. Eddie gets treats when you guys are awesome. More like Eddie demands treats when you guys are awesome. Oh, whoa. Hi. My tripod just like collapsed. Hi, I don't know how to fix this. Okay, so I'm like holding my tripod right now. I don't know how this is gonna work. Giving Eddie a treat. Come on up, Eddie. Come on. There we go. Eddie gets a treat. I hold the tripod. It is all rather awkward. Do it again. No. That wasn't Eddie. That was my tripod spontaneously deciding that one of its legs was going to no longer work. So I will be getting a different tripod today, apparently. So the question was, will there be reading tonight? No, tonight I'm actually going to be giving a talk for the St. Louis Academy of Science, Astronomy on Tap. I'll be in Belleville, Illinois, and if the internet allows it, I will be streaming it from my phone right here on CosmoQuest X. Hello, Eddie. Yes. Here. So, before the world collapses, I'm going to roll credits. And oh wow, I'm trying to get the cursor on the right screen. I will raid somebody in a moment, but first I'm going to rescue the tripod. So wherever you are in the world, have a fabulous morning, evening, or afternoon. And I'll see you with a new tripod tomorrow. Bye-bye.